program developed is user-friendly curve form optimizer by adopting the average curve form design practices by using parametric curve form modification technique. This is parametric curve form modification technique. This is the young design practice. They are not changing lines. They are not changing any, the object nowadays anymore. So, in combination with the local automatic algorithm, say SQP we use, or global optimization. This is derivative free. Later I will explain more detail. Partial global optimization. So curve form modification, first generation, we did like using Hansen dot. Later, this is second generation using Trigon or CAD. And these two computer design software are developed by Korean companies. So some of Korean Shimyak are really recently. And then finally, this second generation still they modify lines. But final goal is without changing any line, the local offset, by changing form parameters, we can generate curve form. If curve form will be one. It is not easy. There's a lot of freedom restriction here. Here, there's no freedom at all. So any kind of shape can be generated by changing, object, that kind of thing. But here, because we are changing only form parameter, the restriction of curve form modification is limited. You get this advantage, but we have to overcome. This is the brief introduction of all the methods of curve modification. Conventionally, by Martel method, point manipulation or data manipulation, and the surface state by nervous or any supply, any competing. By changing vertex control, we can generate, we can modify curve surface locally. And partial, this is a, edit patch perturbation method. Based on, we add some function, edit the function, perturb the function to the original shape. This is a modification function method. Further, we just control all parameters by adding some perturb function. So I will explain these three methods, okay, and this is other method. Next, please. This is usual CAD approach, okay? That is to modify curve surface. This is to modify curve geometry, is removing vertices. This is the curve, this is the surface. These vertices are design variables in optimization process. Okay, the number of vertices are increasing, the complete cost is increasing. Very flexible, no inherent restriction. But sometimes the curve varies is not guaranteed. This is one of the disadvantages for it. Many design variables, that means complete cost high. Limitedly applied in local and or appendix optimization. Next please. This is a curve modification. Originally, the new curve form is plus of these two combinations, the old curve form, and then this perturb function we can use to perturb the patch. This function can be expressed any, but this is our the formulation. We call say that is a bell shape. This can guarantee always a full fairness. Okay, by attaching this kind of bell shape function or three or many, we can generate any kind of geometry we want. Okay? This is the modification function method. Based on this, this is design parametric modification function. Previous one is geometry is modified using modification function, but this is a parameter. Okay, for example, entrance angle, bulb area, section shape, bulb height, quantum height. This kind of parameter are changed using parametric modification function. Okay, so design parameter all plus this is presumed design parameter. This can be a function of one dimension or two dimension, three dimension, depend on the view, depend on the freedom. The original geometry can be easily defined by direct selection of well-known design parameters, as I mentioned here. This is design variable according to computing time can be reduced a lot. Here is always guaranteed. That is the advantage. But still, we are handling this kind of parameter. The restriction of whole generation are limited, as I mentioned. Next. This is an SH curve. This is a preserved function is a function of x. Okay. And the bulb transform shape, and then also section shape. And design line. This is XYZ3 function. This is a parabolic type, and also section UV type. And then we can, introduce this kind of catchy function, modification, and function. But this is up to you. You can generate any type of function. Actually. So now our cases is applied for these two methods. One is the geometry handling, the other is parametric handling by using modification function. We use case X. Design speed is per number is 0.26. Okay. Akimoto he calculated motion using this model. Actually, so this is okay. This is geometry. Object function is total resistance, composed of weight-making plus, form factor and friction. Friction is IPTC. Friction line is used. Design variable is 40% of LPP, 4 part. Is free. So, 40% of 4 part. Total, 40% is change. Constraint displacement 1% plus minus. Key line is fixed and bulb profile can be changed as well. And at 12 station, the generate view hole should be better to the original one. Because we are now, optimizing, we are now optimizing without weighting. We are not changing this, weighting system. Using potential force. Algorithm is, direct searching as should be method. So this is parametric modification. Okay, this is entrance angle. So this is parameter of design error. Instead of this design of parametric modification, bell shape modification function you can see here. Here bell shape. So this is 1, 2, 3, 4, 15 and 1, 2, 3, 4. 19 design variables are used for this bell shape modification function. So we'll compare the result now. Next please. So this is result of original and optimum, 4 part, because after part was not changed. Original and optimum. So this is parametric modification result. You can see here optimum. This full number is 0.26, whose speed is relatively high. This large container shape. So even though speed is relatively high, design speed is high, entrance angle is increased. You can see here, usually entrance angle is decreasing, but this is opposite to our expectation. Actually, same result can be seen here as well. This is bell shape. Bell shape give more freedom, as I mentioned earlier. Similar result, okay? Also, entrance angle is increased. Next, please. This is comparison between two results, parametric modification. We achieve weight-making resistance around 8% equation. Okay? And bell shape modification around 10% equation. But we can